So our topic for today is small internet works. So what we're going to show here today in Riverbed is that we'll make a baseline scenario having 10 nodes connected to a switch and with a server. And then we will expand this network to include another network which will be called our expansion network. So imagine this to be an office and my ground floor has about 10 computers, and then I expand my business and I add one more floor. So I will add one more network to I will add one more floor which will make one more network in my building. That would be my network over here, and these two networks will be connected to each other with means of a router. Now, coming to a few definitions, we have the application definition. So our application definition is basically used to define the various applications that I want to have in my network. So what kind of applications are going to be used in my network. Next, the profile definition. This helps us create the user profiles. So, what kind of users do I have in my office? So I can have engineers, the sales department. We can have the administrator, the finance department employees. So this will help me make user profiles for each one of them and assign them which applications they can use. So that's our so okay. Coming to 3Com switch now. 3Com is the name of the company which manufactures switches. Now, if you click on command palette, you'll see that this has some long name here. So 3C means that we have 3C basically goes to say that this is a 3Com switch. And SS2 means that we have two stacks here, stack 1 and stack 2. These these two stacks are 1100 and 3300. So 1100 is used for our normal switching purpose, and 3300 is used for switching as well as routing. And the layer 2 switch is used to connect network to network. Next, we have 4S, which means we have 4 slots. Then AE52 tells us that we have 52 auto Ethernet sensing ports, and 48E means that we have 48 Ethernet ports. So in all, we have 100 ports, and so we can connect 100 devices to this 3Com switch. G3 means that we have 3 GB Ethernet ports used for uplink connections. Next, Next, I will go on to show you what kind of statistics we want to look at. So I'm going to click on, okay, node 14 is our server. Next, we will go to choose individual DES statistics. And here I want to look at Ethernet stat delay. We want to see Ethernet delay. And also I want to look at server performance. This is not checked. I'll just check it here. Also, I want to see the CPU utilization. So I'm going to click on CPU and click on utilization, and then click on OK. So we have three things: CPU utilization, Ethernet load, and server performance. So global statistics basically define what results you want to see for the entire network, and node statistics are for individual nodes here or for the server as well. So we want to, so that if you want to see node statistics, that means we only want to look at the stats for individual nodes. Next, we go on to the expansion scenario. So we have another network connected here with means of a 2500 router here. Now this router is actually acting as a switch because we haven't configured it to act as a router. Next, we'll run our experiment for 1 hour. Keep the duration as 1 hour. So coming to the results part of our experiment, we click on the run, put the duration to 1 hour and click on run. So here we go to the results browser and now we're going to compare the results between the baseline scenario and expansion scenario. So go to global statistics, Ethernet, and then on delay, as you can see, uh, the delay was initially lower for the expansion, but then it kind of balanced out, it kind of became constant after a while. That's similarly that happened for baseline as well. I'm going to object statistics non-zero was part of the first network. So we click on utilization. So that's the utilization. So we'll compare this for both expansion as well as baseline. So I'll first click on CPU utilization, and then here you can see that the utilization was lower for baseline, it was around 0.81, whereas it increased for expansion it almost went to 0.0004 peak value. So since more nodes have been connected to the network, so more tasks are being performed. So the utilization is increased. Next we need to look at server performance. So in case of server performance, the number of requests going for our baseline are definitely lower for expansion. So you can see that the peak was 0.25 requests per second for expansion, and whereas it's 0.14 for our baseline. And we can also look at Ethernet. So Ethernet will have load bits per second. The load is much higher for our again higher for expansion compared to baseline. So that completes our experiment on smaller internet books. And thanks for watching.